Kalyanra movies ism. Pawan Kalyan's fans have Pawanism. Today's our topic is Booth's algorithm. Not this one. Hi everyone, my name is S.Sathwik Uday Kiran. I am pursuing second year CSCD in VVIT. In this video, I want to explain about what is Booth's algorithm. Without any further delay, let's get started. Let's see first of all what is Booth's algorithm. Booth's algorithm is a sequential multiplier which is used for signed numbers. As you can see here by the definition, Booth's multiplication algorithm is an algorithm which multiplies two signed integers. The approach uses fewer additions and subtractions and straightforward algorithms. Let's understand this with the proper details. Let's move to the next slide. As you can see here, the flowchart is provided for the Booth's algorithm. The first is start. Next one, we are assigning some variables. The A is represented by accumulator, which is initially assigned to 0. Next, Q is the multiplier, and M is the multiplicand, and N is equal to number of bits. Number of N depends upon the multiplier and multiplicand. Later than, here is a condition Q0 comma Q minus 1. Initially, Q minus 1 is equal to 0. We are assuming that. And comparing the Q0 and Q minus 1, which means either that will be 0 or 0, 1 0, 1 1 or 1 0. So let's see what we'll do at the time of these occurrences. First, if we get 0 1, then we have to do A plus M and arithmetic right shift. If it is 1 0, we have to do A minus M followed by arithmetic right shift. If it is 1 1 or 0 0, we directly can do arithmetic right shift. After doing arithmetic right shift, we have to decrement the N value. So N is equal to N minus 1. If N is equal to 0, then we have to end the process. If N is not equal to 0, then again we have to continue the loop. So this is how the Booth's algorithm flowchart works. Let's understand the Booth's algorithm with an example. First of all, in order to know the example, let's see how to do the example with some steps. Let's see the steps. As you can see here, the steps are provided. First one accumulator, next one multiplier, next one Q minus 1, and next one N, next one operation. Initially accumulator is equal to 0, which means all are zeros depend upon the number of bits in the multiplier. So A is equal to 0 0 0 0 and Q is equal to multiplier provided. Next one Q minus 1, initially we assume that Q minus 1 is equal to 0. Next one N is equal to number of bits, and Q is equal to operations performed as mentioned in the flowchart. Let's see an example about this. Here they have given Q is equal to 0 1 1 0 and multiplicand is equal to 0 1 0. Let's execute this. As you can see here, M is equal to and Q is equal to. Initially accumulator is equal to 0 0 and Q is equal to 0 1 1 0. Q minus 1 is equal to 0. N is equal to initial N is equal to 4, later it was 3, and before here I am performing the operation arithmetic right shift. As you can see, the first step we have to consider the Q0 and Q minus 1. Here the Q0 is, as you can see here, one second, as you can see here, this is Q0 and this is Q1, Q2 and so on Qn. Here this is Q0, Q1, Q2 and Q3. Now first step is we have to compare Q0 and Q minus 1. So I am comparing Q0 and Q minus 1, 0 0. As per the flowchart, 0 0 means we have to do arithmetic right shift. So arithmetic right shift, later than the N value will be decreased. The arithmetic right shift for this following is done in the next step. As you can see here, this is the arithmetic right shift of the following code. The 0 is moved to here, 1 is moved to here, 1 is moved to here, 0 0, the 0 moved here, all zeros. The last bit will be 0. This is how the first step works. Now the comparing again Q0 and Q minus 1, as you can see here, 1 0. 1 0 means we have to perform the operation A minus M. So the operation is A minus M. Performing the A minus M, which means 2's complement of M plus A. After executing this, we will get the next step as you can see here, A plus M, A minus M is equal to 1 0 1 1. This is 0 as 0 0 1 1 and 0. After that, we are performing arithmetic right shift, so the N value is decreased. As per the flowchart, after doing A minus M, we have to do arithmetic right shift. So arithmetic right shift, the N value is decreased, that is 2. The arithmetic right shift for this following is mentioned here, as you can see. The right shift is 1, the 0 moved to next one 1, then 1 0 0, 1 is moved here, 1 0 1 1. In arithmetic right shift, we have to assume that the sign bit, I mean the MSB bit must be same before its bit. I think you understand. Here it is 1, so the sign bit after this must be 1. If it is 0, it would be 0. After performing arithmetic right shift, the n operation is 1. For this, the operation, as you can see, 1 1. So we can directly do arithmetic right operation. So the arithmetic right operation for this statement is below, as you can see here. Right shift I am doing 1 0 0 1 1 0 1 1 1. Next I am checking the q0 minus q minus 1. As you can see here, 0 and 1. 0 1 means a plus m, so I am performing the operation a plus m. N is same 1. The a plus m value is like this: 0 0 1 1 1 1 0 0 and 1. After doing a plus m, as per the flowchart, we want to do the arithmetic right shift. As you can see, I am performing arithmetic right shift. So arithmetic right shift, after doing this, we will get the output as like this. After doing arithmetic right shift, the n value becomes 0. The final step to stop the Booth's algorithm is when n becomes 0. So here the 0 0 0 1 1 1 1 0 is the result of our given question. M is equal to 0 1 0 1 and q is equal to 0 1 1 0. When we convert into binary, these are 5 into 6, which is equal to 30. As you can see, when we convert the result into 0, then it is 30. Let's check the verification. As you can check here, m into q 0 1 for the verification general I am multiplying 0 1 0 1 0 1 1 0 with a multiplier and multiplicand. After multiplying this 0 0 0 1 0 1 0 1 0 1 0 0, after doing this I will get 0 0 4 1 and 0, that is equal to 30. Therefore the result we get in the Booth's algorithm and the verification is satisfied. Therefore the result is matched. This is how the Booth's algorithm works. This is how the Booth's algorithm works. Thank you. This is about Booth's algorithm. Arigato.